Today's lesson is on factoring trinomials by trial and error. Before we move on, I just want you to notice on your paper where it says the general form of a quadratic expression is always in the format ax squared plus bx plus c, which you probably have noticed when you are asked to multiply two binomials together. So what I want you to do is look at question number 1, where it asks you to multiply each expression below. Remember, we learned two different methods in order to multiply binomials together. One of the methods is using the box method or the geometric model, and the other method is using the distributive property. So for question number 1, I want you to use the box method, because what we're going to learn today, we're going to refer back to this box method and then eventually to the distributive property, and I want you to understand how those two things are going to be linked together. So please go ahead and set up your box for this problem. Press pause, see what you get as your answer, and then confirm with me once you're done with the problem. Go ahead. So you should end up getting 3x squared plus 10x plus 8, which was a result of combining these like terms right here. That's how you got the 10x. And then you already knew the 3x squared and the 8, and there was nothing like it to combine together. So your final answer is this trinomial right here, 3x squared plus 10x plus 8. Now remember, we talked just now about the general form of a trinomial. This means that the a value in this expression will be 3, the b value will be 10, and the c value will be 8. Okay, now that we've done the first example using the box method, I'd like you to use the distributive property for the second example, please. So go ahead and figure out what your answer will be, and then again compare your answer with mine and see how you did. Please press pause, and then when you're ready to go, press play again. So if you notice right here, when you multiply or distribute the 5x to the 2x plus 1, you end up getting 10x squared plus 5x. And then when you take the 3 and distribute it to the 2x plus 1 here, you end up getting 6x plus 3. You have your like terms 5x and 6x, and that's how you ended up getting the 11x. So in this example, the a was 10, the b was 11, and the c was 3. So looking at this method, there's something very important that I want to make sure that you notice, and that is where the a value and the c value come from. So just like we just said, the a value is 10, and if you notice, when you multiply the first term in each set of binomials, you will end up getting 10, and then obviously x squared. So this right here, this 10, comes from the first term in each set of binomials. Now if you notice, the c value is 3, and that comes from the last term in each set of binomials, so you end up getting plus 3. But don't forget that when you distribute, you don't just multiply this 5x by this 2x and this 3 by this 1 and then you're done. You have to multiply the 5x to the 1, or the outer, and you also have to multiply the 3 by the 2x, or the inner terms. So what I'm going to do is I'm going to put some carets. So these carets right here give me 6x, because 3 multiplied by 2x is 6x, and then this gives me 5x. And when you combine those like terms, that's how you end up getting this b value right here of 11. This is going to be really important and really helpful when we're going through and factoring. Now remember, just like with factoring by GCF, when you factor, you're just basically undistributing the trinomial into the product of two binomials in these examples. So what you're going to do is this time you're going to be given the problem like this, and you're going to be asked to put it back into the binomials here. This is going to be very helpful in the next unit when we solve something called quadratic equations. We're going to try the following examples. So if you look right here, we have 3x squared minus 2x minus 8. So what I'm going to do is I'm going to try to take this example right here and put it back into the binomials that I would have before I use, in this example, the box method to multiply it together. So remember, when you do this, you're going to have two terms right here, your first binomial on the top and your second binomial on the bottom. In order to do this, I need to figure out what what expression would go right in this middle box right here. So, if you look right here, I know that 3x squared has to go here because my ax squared term is always going to be the result of the first two things being multiplied together. Similarly, I know that the negative 8, the c value, has to go in this box right here. So this multiplied by this has to give me 3x squared, and then whatever term I put on top of this box right here and this box right here also has to multiply out to give me negative 8. So what I'm going to do is I'm going to try to list out all the possible factors of 3, but that's easy because the only factors of 3 are just 3 and 1. And then I'm going to do the same thing for 8, all possible factors of 8. That's also easy again because the factors of 8 are just 1 and 8. And, 2 and 4. That's it. So in this example, the terms that go up on top right here and on the side right here are easy because I only have one choice. I have to put a 3 here and a 1 here. Again, I can do it in the opposite order. That's fine. It doesn't matter. So then what I'm going to do, again, because this is trial and error, I'm just going to try my examples right here. So my first set of factors is 1 and 8. So I'm going to put my 1 right here, and I'm going to put my 8 right here. Now, I'm not going to worry about the signs for right now. I know eventually it has to multiply out to give me a negative 8, but I'm going to figure out what the signs are at the end once I figure out what the proper numbers are that I'm going to need to put here. So now here's the question. What value goes in this box right here if I put the 1 here and the 1x here? So if you go through and you just basically multiply it together, this ends up being just x. And this ends up being 24x. Now, don't forget that you want these two terms right here to multiply out to give, to add up to give you this middle term right here. Unfortunately, there is no possible way that x and 24x, no matter what the signs are, there's no possible way that those two numbers can give me a negative 2. So that is out. I'm not going to use that example right here. So what I'm going to do next is I'm going to switch the order of the 1 and the 8. So I'm going to try the 8 here instead, and I'm going to try the 1 here instead. And I'm going to see what ends up happening. So again, I'm going to figure out what goes in this box. So right inside of here, I know that that's going to be 8x. And I know here I get 3x. Again, I'm going to look at these two numbers right here, and there's no possible way that I can get this negative 2 from 8x and 3x, so that's out. So I've exhausted all possible ways that 1 and 8 will work, so I'm going to cross that off my list. And now I'm going to try it with 4 and 2. So again, I don't know what the order is, so I'm going to try it, see what happens. I'll try the 4 here, and I will try the 2 here and see what happens. So if you look right here, this ends up giving me 4x, and this ends up giving me 6x. So I'm going to ask myself, is there any possible way that I can get this negative 2x right here from a 4x and a 6x? And yes, there is a possible way if the 4x right here is positive and the 6x right here is a negative 6x, which means that this 4 right here has to be a positive 4, and that this 2 right here has to be a negative 2. So then I look at what I have right here on top, and this on top is what gives me my first binomial. So if this says 3x plus 4, then I just got to fill in 3x plus 4 right here. And then if this right here gives me 1x minus 2, then I know that my binomial right here should say x minus 2. And then I can check to make sure this is right by going through and either using the box method, or I could actually go through and distribute my values to figure out if this works. Okay, so here's another example, and if you notice there is no box because I want to show you how to do it without the box, and then you can kind of see which method you prefer and follow the one that works best for you. So in this example right here, again, your goal is to get these first terms to multiply to give you your A term, which is this 3 right here. So I'm going to look at all possible values of A, of factors of A, so my choices are only 1 and 3. Same thing with the last two numbers. The last two numbers in my binomial should multiply together to give me my C value right here, which is 14, negative 14. So I'm going to look at the factors of 14, and I'm going to see that they are 1 and 14, 2 and 7. So the first terms in my binomials are very easy because my only choices are just 1 and 3. So I'm going to try a 3 right here, and then I will have 1x right here. I technically don't have to put the 1 there, so I'm not going to. Now, for this one right here, I'm going to see what two values I can put here that will multiply together to give me this 14. But if you remember in this example right here, the two the inner and the outer terms right here will add up to give you your B value right here. So I have to figure out how to get these two terms to add up to give me my B value, which is, in this example, the 1, because there's an invisible 1 in front of this x. So I don't know what values are going to work, so I'm just going to try. Again, this method is trial and error, so I'm just going to go through and I'm just going to try some examples right here. So I'm going to try a 7 right here, and I'm going to try a 2 here and see what happens. So I'm going to figure out what these values right here are going to give me. So this, when I multiply, when I go through and I distribute it, this will give me 2x, and this right here will give me 21x. And I'm trying to get 1x from this. And if you look at the values that you have, this 2x and this 21x, there's no possible way that you can get a 1x from a sum of any combination of those numbers, regardless of what the signs are. So that is not going to work. It doesn't necessarily mean, remember, that 2 and 7 don't work. It just means that 2 and 7 in this order don't work. So what I'm going to do now is I'm going to try the 7 here, and I'm going to try the 2 here. And I'm going to see what happens. So if you look right here, same thing. I'm going to figure out what I get when I multiply this 7 by this x, so I get 7x. And then I'm going to see what I get when I multiply this 3x by this 2, and I get 6x. And lucky for us, there is a possible way that you can get this 1x right here from this 7x and that 6x, and that is if the 7x is positive and the 6x is negative. Remember, 7 minus 6x gives you 1x, or just x. Because this 7x has to be positive, that forces this 7 to need to be positive, since this x is already positive. So I'm going to put a plus sign right here, and then I'm going to figure out what goes right here. Because this 3x is already positive and I need a negative 6x, that means that this 2 has to be negative, and that is my factored form for 3x squared plus x minus 14. Alright, now in example number 5, if you notice, there's a leading coefficient right here of 1. Remember, the leading coefficient is the number, the first coefficient that you see in your example. That makes things a lot easier because the only possible values that I can get to multiply together to give me this x squared are just plain and simply x and x. So I have the x here and the x there. Multiply it together, you get x squared. Now remember, your last two terms right here, this one and this one, will multiply to give you your C value, which is negative 20 in this example right here. So what I'm going to do is I'm going to look for all possible values that can be factors of 20. So my possible values are 1 and 20, 2 and 10, and 4 and 5. So what I'm going to do is I'm going to figure out how these two boxes, this box here and this box here, will combine together to give me this B value, this 1. Because this is 1x and this is 1x, I don't have to worry about multiplying this term by this term here, because anything multiplied by 1 will still give me that value right there. So that narrows down my values for what I can pick from factors of 20 a lot more easily, because again, I'm looking for somehow I can get this 1 right here. The only way I can get a 1 is if I use a 4 and a 5. So what I'm going to do is I'm going to try a 5 here. if it lets me drag it. And then I'm going to try a 4 here. And I'm going to figure out what I get when I do my multiplication. So when I do this, I end up getting 5x right here because x times 5 is 5x. And then I end up getting 4x right here, which is what I want because 5x and 4x, if the 4 is negative, will give me this value of 1 right here. So that means that this 5 has to be a positive 5, and that this 4 has to be a negative 4. Then I can just take this expression right here, this expression right here, fill it in, and that is my factored form for x squared plus x minus 20. Same thing, you can go through and check it by distributing or using the box method. In this last example right here, I am going to not use the box method and I'm going to use the distributive property method instead. Notice though that the leading coefficient here is a negative number, which is something we're going to have to be taking into consideration very shortly. Since the leading coefficient is negative 2, I'm going to look for factors of 2, which are just 1 and 2. And then I'm going to look at the C value and I'm going to look for factors of 9, because remember this number and this number multiply together to give you that 9. So the only possible factors of 9 are 1 and 9, 3 and 3. So the first part is very easy because all I have to do is put a 2x here and then put an x there, and that multiplies together to give me 2x squared. I'm ignoring the negative for right now because I'm going to fill in the negatives at the end. And then I'm going to try to figure out what values will go right here. I'm going to try the 3's, see what I can get from these 3's right here. Remember, I want my 3's to multiply out to give me a positive 9 right here. But again, I'm going to ignore the signs for right now. So I'm going to go ahead and use this right here. See what kinds of values I get. I know that this is going to be 3x, and I know that this is going to be 6x. And lucky for us, I can possibly get this 3x from these two values right here if this 3x right here is a negative 3x. Once I have a negative 3x here and a positive 6x here, I know it adds up to give me a positive 3x right here. Now here's where it gets a little bit tricky. I want to have it so that my leading coefficient is negative 2. So one of these two values has to be a negative value. So because this right here is a negative 3x, I'm going to put a negative x right here. Now that satisfies this negative 2x squared, because 2x multiplied by negative x is negative 2x squared, and it also makes this negative 3x right here negative. And then I want this to be positive, so that would require these two values right here to both be either positive or both be negative. But if I make this negative, then this won't turn out to be a negative 2x squared, which means this has to be positive. Therefore, this has to be positive. Let's just double check to make sure that it really does multiply out to give me a positive 9. 3 multiplied by 3 is positive 9. 2x multiplied by negative x is the negative 2x squared that I want, and these two inner terms right here will add up to give me the positive 3x, so I know that that is correct. So my factored form of negative 2x squared plus 3x plus 9 is the quantity 2x plus 3 multiplied by the quantity negative x plus 3. One quick note that I just want to make sure that everybody understands, because I haven't mentioned this yet. It is totally fine to write your answer out as negative x plus 3 multiplied by 2x plus 3, because the commutative property says that you can put this in any order that you want, as long as the signs remain the same signs that you had before. So another example is right here. In this example right here, I can still write my answer out as x minus 4 multiplied by x plus 5. And that's how you factor trinomials using trial and error.